My name is Casey, and I'm a front-end developer at TrueHome. And I'm going to talk a little bit today about what I'm calling finite jest pragmatic unit testing. So this is our beginner talk, but I'm hoping there will be something in here for everybody. I'm going to talk a little bit about what unit testing is and why you should consider doing it, or maybe how you could convince your managers to consider doing it, especially if your manager's here tonight. How to get the most out of testing, and then I'm going to get a little more into the weeds and talk specifically about the Jest framework and why I like it. And then I'm going to go through kind of a simple example that shows how I think about unit testing and also goes through some of Jest's features. But the main thing I want to talk about is kind of the philosophy behind testing and test-driven development, and this can be sometimes a controversial topic, so if you have anything to add, please chime in or hit me up at the end with questions. There is going to be some code in this talk, and I'll go through it, step through it slowly if I have time, but it's also in a GitHub repo if you want to check it out after. So I guess the first question is, why write unit tests? If you've looked at well-tested code on GitHub or something, you probably noticed that there's often more lines of test code than the actual implementation. And in fact, one study, and others have borne this out, but one study that I'm referencing here actually estimated that there's actually a 30% more build time if you follow the TDD philosophy, that's test-driven development philosophy, and write all of your tests before writing the implementation. But the flip side to this is that that process can reduce the density of production bugs by anywhere from 40% to 80%. And production bugs cost more to fix, they make developers unhappy, and most importantly, they make users unhappy. And if users leave your app or your website, they might not come back. So really, TDD saves money. So in this fictional example, which you can check out from Eric Elliott, he has to make a number of assumptions. I noticed there's actually no scale on this graph, so my scientific past life is screaming at me, but it's all relative anyway. So if you assume you have a project that, say, takes 1,000 hours of developer time to build out initially with no test-driven development, even if you add that 30% time onto the initial build out, you'll save it back and then some in the maintenance that you're doing later on. And of course, this makes a lot of assumptions. The biggest one is how many bugs sneak through to production. So maybe if you're just a brilliant developer and don't make mistakes, then you don't need to do this. But what I was realizing as I was putting this talk together is that really the testing process is about writing brilliant code to begin with, more so even than it is about catching bugs. So what is unit testing? What unit tests really do is they document or they prove the functionality or the specification of an isolated unit of code. And what that allows you to do as a developer is think about code in isolated chunks, after which you can sort of treat it as a black box. If that piece of code does exactly what it's supposed to, then you don't really need to worry about it later when you're designing other units or when you're designing the way that they'll interact with each other. So to take one sort of extreme example, I sometimes contribute to a project called StyleLint. It's a linter for CSS as well as CSS-like languages. And it can be run in all kinds of different ways. Because it's a linter, it can plug in with different editors. You can run it from the command line. There's a Node API, etc. And if the maintainers of this project were to have to test all of the changes made to it manually, it would be an incredibly arduous process because it has all of these different contexts that it can run in. But as a contributor to StyleLint, all you really need to understand is the one rule that you're working on and the one, CSS thing that it's supposed to evaluate. So just to give you an example of what these tests look like, all you need to do is write some CSS that's either valid or invalid and specify whether the test is supposed to be rejected or accepted. And and if there's an error, what line it's on. You don't even really need to be a user of StyleLint to contribute to it, because it's so simple to look at these objects in isolation. Oh yeah, sure. This is not the way that unit tests normally look. I'm going to go through a more straightforward example. This actually passages it through Jest in sort of a higher order way. So all it is CSS and what the linter is supposed to do with it, basically. And in fact, we have more than 13,000 tests in this project, and it makes it pretty easy to tell when something's working the way it's supposed to and when it isn't. So that sounds pretty good. There are a few things you can do that can make that 30% of time, or whatever it is, the most efficient that it can be. Probably the biggest one is that the units that you're testing really need to be isolated blocks. And the reason for this is that otherwise, when you refactor, it isn't clear whether a given test is supposed to pass or fail. If you are testing units, then if you refactor within the unit, then all the tests should keep passing. If you're refactoring broader concerns, then maybe you actually need to redesign the specification for that unit and rewrite the tests. If you're interested in this, you can check out this blog post from Steve Sanderson, where he goes into this in a lot of depth, and why you shouldn't write these sort of mixed tests that test broad parts of your code but not the entire code base. Another thing you need to be aware of is that testing is easier for some types of code than others. So the easiest type of code to test is pure. So what I mean by that is, given some defined input, it will always return the same output. And it's synchronous. It doesn't talk to a network. It doesn't have, set timeout or other of these wonderful JavaScript asynchronous processes in it. On the other hand, it's hardest for code which is asynchronous, which has side effects, so it maybe calls other functions that mutate something but aren't part of the output of that function. It depends on its context, which can include either referencing the this keyword or closures, or it mutates stuff, which includes the DOM and database records and things like that. So does that mean you shouldn't write code that has side effects or that mutates stuff? Of course not. All apps need to talk to the network, need to talk to the DOM. But if you put the logic inside of the code which is easiest to test, it's easier to reason about your code, it's easy to understand how the tests are behaving and how the code is behaving. Okay, so to do this, there's a bunch of different parts to the testing framework and how they work together. So you need a test runner. You need some sort of assertion library, which is basically just taking your expectations and causing them to throw errors if they aren't met. And then you'll need some way of doing what's commonly called either spying or stubbing or mocking, depending on the specifics of it. But basically what it is a way of creating functions that can be passed into the unit that you're testing and seeing whether they're called and whether they're called with the right things. That part is kind of optional. For truly pure functions, this maybe isn't necessary. The things that I like about Jest is that it does all of these things together. You might have worked with Mocha or Chai, and you have to pick these different parts that that work well together, and then you need something else for the mocks. But Jest has all of these different parts built into it. It has an expectation library, which I think is big enough that you can really do anything with it, but it's not overwhelming. It also works really with zero configuration, so you don't have to spend a lot of time setting it up. And it has a nice command line interface and interactive watch mode, so you can you can see the behavior of your tests really well from the terminal. Okay, so now I'm just going to go through a really simple example. This is a button. I have here a button. All that happens when I click this button is it calls a fake API, and it displays a version of the response on the screen. So the API is written in the server file, and what I did is I programmed it to fail about half the time, or exactly half the time. So sometimes I call this API, I'm going to get an error. Other times it's going to spit back. Make this bigger. Well, anyway, it's going to spit back a house price of $450,000. Okay, so that time it failed. That time it failed. Uh-oh, it's failing all the time. Oh, there we go. Okay. So you'll notice this is not the number that the server gave me. This is a nicely formatted string that a user can easily read. So there's a few different parts to this app. The easiest part to write tests for is going to take our house price, which is a number, and format it as a string. So, cancel. On these slides? It doesn't really matter. I'm going to go into the editor now and mostly just show code. So, okay, so I'm going to write a format price function. Let's just close that. Which is going to take a number and format it as a whole dollar price. If it's greater than $1 million, it should use M in place of that price. If it's greater than $1,000, it should use a K in place of thousands. And one of the reasons that unit testing is really powerful for catching production bugs is it allows you to think about edge cases. So I know that a house price really can't be negative, but sometimes even back-end developers make mistakes, and it's possible that my API will return data that my app isn't expecting. So I've got a couple of edge cases programmed into here, or spec'd out in here as well. So the next thing I'm going to do is write some failing tests. So really all I'm doing is passing in some numbers into the function and then comparing them to the value that I think I should get out. And this is even easier to reason about than writing the actual implementation code because anybody can tell what I should be getting given the expectations of my spec. And then finally, once I've done all of that, then I'm going to write the actual implementation code. Nope, that's not it. So you can see that here. There's, of course, a number of ways you could have done this. Your implementation probably would have been different from mine, but if you were another developer on this project, you probably wouldn't even care. If you looked at the specification, you could tell what the unit was supposed to do. Okay, so I talked a little bit about mocking when I was introducing Jest, so I'm just going to go through an example of that so that you can see how it works with this framework in particular. So this function is supposed to call an AJAX library and return the price based on whether the library passes a valid status code or not. So if it doesn't, it's going to tell the app to pop up that alert. But if it passes, it'll just pass on the data. So the only real complication is that it uses a promise, and that it's accepting a function, I guess, as an argument, which is a little bit different from what we were doing before. So my real API passes some of the time, or errors some of the time, and returns a valid value some of the time, but I don't want my test to reflect that because I don't want any sort of indeterminacy. So what I've done is write a couple of mocks in Jest, just using this jest.fn method, and then passing in an implementation into that function. So basically that means that when this function is called, it will execute this function and return the value, but it'll also keep track of it so I can test expectations based on what the function should do. So like here I have a test that says it should call the Ajax library, and I'm expecting that function to have been called. Sorry, I can't hear you. Oh, Zoom. Did that work? Yes. Is that better? Okay. I'm also expecting that I'm going to be getting a promise back because this is asynchronous code. And there's a couple of ways you can do that. First of all, because it's just a promise, I can call then and then put my expectations inside of the callback function, or I can just use this resolves tag, which is a lot easier to look at. And then once again, I'm going to write the implementation. And it looks like this. It's basically just a wrapper around an Ajax library called Popsicle. And it's accepting a function as an argument and then setting the default of that to just the get method of Popsicle rather than the mock functions that I'm passing in. Finally, I'm using React to create the UI, and while I sort of said at the beginning that maybe you shouldn't test code that mutates the DOM or you get less value out of that, it's actually pretty easy to test React components. I'm not going to go through the whole different Git branches here, but basically I can use this library called Enzyme, which sort of renders the React component inside of a fake DOM, and then you can test expectations like if the button is clicked, it should call a function that I'm passing into that component as a prop. So this is, I think this is really pretty cool because like as a front-end developer, of course, components depend on sort of their styles and where they fit within the rest of the DOM, but you can also test sort of their raw functionality in this very agnostic or automated way as well. So that's really all I've got. Just take any questions.
Okay, so I refuse to write tests at the beginning. I write tests once let's say the core is ready, right? And that's just my view of things, right, because I'm trying to be faster. What's your view? Like, what do you think? How the test-driven development is a thing, and there's a lot of people that say that's how you should start. You should write the first test and then develop your code, right?
Right. So I think your own experience is in many ways more valuable than like the collective wisdom, but on the other hand, your way of doing things is going to feel more efficient to you at the beginning, is always going to feel more efficient to you. So I do find, especially for like that kind of sweet spot of, units that are pure and synchronous, I get the most mileage out of writing the tests at the beginning. Sometimes with more complicated functions, it's really hard to reason about what the expectations are unless you've at least sketched out the implementation. But like from my experience, I think writing the tests first works. And I think that the collective wisdom, and to the extent that you can study this, that's sort of been borne out as well.
Do you have any opinions about whether this Jester testing framework is equally useful, whether or not you're doing test-driven development?
I think all testing frameworks kind of do the same thing, so I'm not sure that it really matters. I like Jest for the reasons that I went through, but obviously like how you use it matters a lot more than which framework you pick. Does that answer your question?
I'm curious with the asynchronous testing kind of helpers, like the resolves and rejects for promises, for example.
Yep.
Does it have like a built-in timeout if the promise like doesn't resolve?
Well, you'll notice these I had to return, so the tester is keeping track of the fact that it got past a promise, and it expects it to resolve or reject at some point. If you forget this return statement, the test will always pass. So that's kind of a gotcha. I'm not sure if it times out. I haven't tried like putting like a really long set timeout as a promise or something like that.
This is less a question, more a suggestion for further reading. I know Abram Hindel's group at U of A have been doing sort of studies of how people actually code.
Okay.
And they published a paper last month in November that was looking specifically at the idea of, is it better to write your tests before you write the code, and basically looking at GitHub repositories that were using various testing frameworks and looking at when the commits came in and were people committing the tests at the same time or before they were committing the relevant code. First thing they found was that in most of the cases people weren't. The number of repos that were really following a strict test-driven development was small, and then they were looking at other things like issue sets, and I don't think they found any significant differences with test-driven development, but of course, as you said, it's all about having a good system and a structured approach, regardless of the details. I mean, certainly, I think we all agree that writing the test before you push to production is the most important thing, and writing tests before you make any line edits to production. Anyways, probably find that tweet or something and send it out. But
Yeah, if you could tweet that to Edmonton JS, I'll look out for it.
I know one thing that really has helped me with my tests is like thinking about kind of acceptance and assurance tests. And so like I'll have acceptance tests that I try to write, and they're usually like higher level, maybe integration tests or something, where I'm focusing on, what the business would care about basically, or the customer would care about, and trying to write tests that match those expectations.
Right.
And then on the other side of that, I have what I would call more like assurance tests, which are like, as a developer, I know like if this can receive a number, that number we should make sure, does it handle zero as a negatives? And those are more like just making me as a developer feel better that the code is robust and stable and all those kind of things.
So would you say your acceptance tests are more like integration tests?
Yeah,
Sort
like
of testing the behavior of the system rather than...
Yeah, like it would be the high level
Yeah.
stuff, like, if you have a shopping cart, can you add an item to the shopping cart? And then, my assurance test to go with that might be like, if you set the quantity of an item to like -1, how does it handle that?
Right.
Stuff like that. So that would be the difference where I kind of approach looking at it to see if I've got all my tests in place and things. So the other time too is I always try to write a test if I have a bug. Like if I know there's a bug, especially when we're seeing in production, I'll try to write a test first to like capture that regression. Because sometimes too, like you miss the actual behavior that's causing the bug.
Right.
You assume it's one thing and then you fix it and then realize it's not actually what was broken and the bug's still there. So those are 2 times that I find writing tests useful.
Oh.
Just a general question. As someone who's not in the JavaScript community, like, is this a kind of a live issue, testing of code? Because like this, the client side stuff, I mean, it's all kind of happening. With a language like JavaScript, I imagine bugs for larger scale projects could be a problem. So this would be a way to mitigate it, right? Is that something that's
mitigate probably even most of the projects of architecture is a thing to not just words. Sorry. So I think like a proper architecture goes before testing. I mean, testing is important, of course, to see once something changes, to test if that change has an impact on a specific function. But I don't think you will get rid of. I don't know. It's like maybe I haven't worked on large scale projects, and maybe Ben has something to say.
Yeah, it's absolutely still a live and contentious issue, and I don't know if it will ever go away. You still see arguments being made that you shouldn't be writing tests at all, and I think it's worthwhile to read those arguments. They have some legitimate points, and there's always kind of like the overall feel of the community tends to swing, back and forth. I think over time we've kind of moved to build a little bit closer on average towards test-driven development. But I think the other thing that you're seeing is a lot more aggressive use of other tools to try and reduce bugs. So things like TypeScript that add some more structure to the language, things like linters that like just make sure that you're writing the code in a conventional way where it's easier for your eye to visibly detect when code might not be behaving the way that you expect it to be. More enforcement of conventions in terms of naming conventions and things like that. Like these are all tactics that work towards making a product work more consistently. And by no means do tests fix those problems. Like one of my big reasons believing in test-driven development is your tests are actually verifying the behavior. Like there's the phrase red green refactor, where you write a failing test, you make that test pass, and then you make your code better structured, so that that test was initially failing. It's really easy to write tests that you think are actually testing the thing, and find out that the test wasn't actually testing anything at all, was just always going to pass regardless of what the code was actually doing. But yeah, there's like these debates are gonna I think be going on for forever, as we're always just searching for what's the right balance between developer happiness, developer speed, productivity, robust applications. Like there's so many factors in play that finding that right balance is a real challenge.
I would say it's a live issue because we're continually pushing this concept of building an application inside of a browser. And in the jQuery days, I don't know that unit testing was really a thing, but what you were trying to do with jQuery was much simpler than what we're trying to do with React. So, and then at the same time, like having these more robust processes allows things to keep getting more sophisticated, and so the libraries keep getting more sophisticated, and then the apps keep getting more sophisticated, and then the test, it just goes around in a circle. So
I think one big thing when you get into bigger projects and more complex things is kind of expands on everything Ben was saying, is also some cultural changes. And one thing we see in our code, we have like 40 developers, you often end up people putting code in places that they're familiar with rather than where it should go, because you're scared to touch that other code because there's no tests around it. And having tests around the code, it's a lot safer refactoring the code and making changes to code that you're not familiar with.
Okay, and I want to add some my experience, because I've been using Java as a backend development for about 20 years. So I have worked with lots of the clients, lots of projects before. So my experience is most of the project, if they just lack of the unit test or any test, or they just ignore the test, usually fail miserably. So, for example, a client, they have worked on this for about 4 years project, huge project, and later when I came in, they just skip all the test. So when you run the build, they skip the test, and the project is horrible because if I don't run a test, I don't know how my change will work or not. But my current client, they're very successful, and they have very strict code review process. When they have code review, you have to put in your unit test at full coverage, and they have the Solar, they have tools to analyze your code to make sure your unit tests cover like a certain percentage. If you fail, you won't let you pass the code review. And they are very, very successful. Their project moving on from 2002. So right now it's about almost 15 years. And it grows from Spring, like Spring 2 right now to Spring 4, now moving to Spring 5, Java 8. It still can moving. That's my experience is why we need a unit test is not because like we have some safety. It's because we make sure when we change, we can change. Otherwise, you cannot change because code is so brutal. It's kind of, you touch any part of it, it will fail. So nobody want to change, then the code will dead. But with unit test, we can easily find out what kind of change will break other part. Now we can fix that. Now we can grow. So that's my experience. I found out this all the testing, unit test, integration test really help you grow your code base. Otherwise, your project will die very soon without test. Yeah.
Yeah.
All right,
You
thank you
bringing
very
your
much.
own computer?
Exchange.js is Edmonton's JavaScript meetup. Thanks to our sponsors, Jobber and Investopedia. Support the meetup and like and share this video. And stay informed by following us on Twitter and meetup.com. Links in the description. See you soon!